Okay, good morning, friends. We were day before yesterday. We were solving some problems on arrays, and here we have solved the problem of linear search. So now let's trace program. Is that is where we had left. So let's trace the program. See here we have taken an array of type float. Okay, and then the search key, that is nothing but one of the elements in the array we have to search, so it is also float. And then the size is nothing but the size of the input size is given by the user, and the position where the search element was found in the array is will be stored in the position. Okay, then what we'll do is we are going to read the number of elements the user wishes to enter, and then we are reading the numbers here. Okay, this loop reads the numbers. Okay, that is the data from the data is read using this loop, that is using the scanner. Then enter the element to be searched. So the search key to be, so the element to be searched is read, and then we are calling the function linear search. Okay, to the linear search we are sending the address of the first element and the search key and the size. Okay, right. So these are all the things that we have sent to the linear search function. So when we come here, see, please note, this function will return one integer value that we will store it in position. Position is nothing but the position is nothing but the the position is nothing but the position where the element is found. Okay, in case if there are multiple copies of the search key, then the first entry, okay, will be returned. All right. Okay, so let's continue here. In this function linear search, we are receiving that address of the first element in a pointer. Please note the elements are of type float, so the pointer is of type float. Then the key is also of type float. Then size of the array. Okay, size of the array is I mean the number of elements that are there in the array. Okay, that is given by the user. Now next, here in this loop, that is the for loop, we are searching for the element. Say suppose if the element is found. Okay, right. So here match happens. Okay, so if the match happens, that is the key is found in the array, then what we will do, search successful and return the position. Please note, I will be the index. Okay, plus 1 will be the position. The position starts from 1 but the index starts from 0. That is the reason I am returning I plus 1. Okay, right. Now say suppose we have scanned through all the elements of the array but we did not find the element, so we will return -1 once the control comes out of the loop. Okay, right. Now here let us take an example. Okay, so now say the elements in this will be something like 10, say 20, 5, 1, 15, 0, 9, 3, 6. These are the elements of the array. Assume this is the name that we have given is ARR. Okay, the address of this is again 1001. Let us assume. Okay, floating point is what? It is of size. Floating point is of size 4 bytes. So this will be 1005 and this will be 1009. Okay, right, and so on. Okay, right, 1013 and so on. So that is how the addresses of the elements will be. Okay, so this will be ARR of 0, ARR of 1, ARR of 2 is 5, and so on. Okay, now assume here we are searching for the element, say key equals 5. Now key is found at the position 3, nothing but index 2. Okay, right? So this function here, that is linear search, what it will do, if ptr of I, okay, the ptr is holding the address of the array, okay, and through that we are dereferencing, we are doing the pointer arithmetic and dereferencing, and we are reaching to the elements of the array, we are reaching to the elements of the array. Okay, right? So here one thing that you have to note is when we write ptr of I, okay, what it is star of ptr plus I. Okay, right? Now what is ptr? Now ptr is nothing but the address of the first element. Okay, right? So here we have this ptr. Okay, to this ptr, what is that we are sending? The address of the first element, that is 1001. Okay, so come to this. Now when I say star of, say ptr of 0, that is the first element, okay, which is 10, correct? How do we get it? Value, what is that? Star. How do we get it? Please observe. ptr of 0, when I say it is star of ptr plus 0. Okay, star is value at ptr means 1001 plus 0. Okay, value at 1001 plus 0, nothing but move to the same element. Okay, right? Or in other words, move nowhere. So value at 1001 is 10. That is nothing but ptr of I or ARR of 0. Okay, I hope you are trying to understand this. Okay, yeah. Okay, so now next is let's continue. So now say suppose we are searching for an element that is not present in the array. Okay, say we are searching for 50. Okay, right? So in that case what happens? In that case what happens is, now we will search for 10, that will be no match. 20 is equal to 50, no. 5, no. So like this all the elements will be scanned, then the I will become equal to size. Okay, it will become equal to size. So when I is equal to size, the loop breaks, then return -1. So here what we are checking, position will get here -1. Okay, so here position will get -1, and position not equal to -1 we are checking. Okay, position not equal to -1 means the element is found. Okay, the element percentage f was found at position percentage d is what we will say. Otherwise, if position is -1, we will say the element was not found. Now what is that we have to observe here is, come here, see what is the best case efficiency. Best case efficiency of linear search, what is the best case? The best case of linear search is when the very first element is the search element. Okay, when the very first element is the search element, nothing but in our case 10. Okay, so in our case 10. So when the element is 10, how many searches? There will be only one search, isn't it? Right? So there will be only one search. All right, so there would be only one search, isn't it? Okay, yeah. See, in the best case efficiency of linear search would be when the search element is found at the very first position. So how many searches will be there? Only one. So what will be the best case efficiency? BCE means best case efficiency is O, big O. Okay, big big O of 1. Okay, we use usually big O to know the worst case efficiency. Okay, usually, but we can also mention the worst and average cases also. Okay, the big O primarily works on the input size. So input size is n. Assume the input size is n. Okay, so for the input size n, how many iterations will be there for this loop? N iterations. Okay, right? So there will be n iterations. Okay, now what is the worst case efficiency of linear search? When the element is not found, isn't it? When the element is not at all found, then how many searches will be there? N searches, isn't it? Okay, the worst case efficiency of linear search is when the element is not there or the search element is in the last position. Okay, right? So worst case efficiency is big O of n. Okay, now comes the average case efficiency. See, the average case efficiency means what? The element is found somewhere in between. Okay, in between means what? At position n by 2, n divided by 2. Okay, now the big O will not give you the efficiency which has the constants and all. The constant here is half. Okay, n into half, isn't it? So that constants we have to remove. Okay, so what is the average case efficiency of linear search? It is in the order n itself. See, please note the big O actually gives the order. Okay, the order of the algorithm. Okay, now here linear search means it is only linear one. Okay, just in one line, isn't it? See, this is just one line. Okay, right? So this is just one line. That's it, right? Okay, so linearly we search, that's it, over. Okay, there is no more interior we go and search. It's nothing like that. Okay, right? When we come to the sorting techniques, you will see the algorithms will be bilinear, mean to say we'll be using nested loops. Okay, so a nested loop means for every outer loop we have to do the inner loop. Okay, and repeatedly, right? So there will be so many lines. Okay, multiple lines, so that will be in the order of n square or n cube. Okay, depends on how many loops and how we are nesting them. So now here, please come here. Case efficiency is when the element is found at the very first position. The worst case efficiency when the last element is the search element or there is no search element in the array. And the average case efficiency is also big O of n. Okay, the average case efficiency looks like big O of n by 2, but please note, for we consider the big O for very large n, for very large input size. So when n is very large, okay, n by 2 is also very large. Okay, right? Say for example 10 crore elements are there. Okay, right? So in that in that 5 crore will also be very large, isn't it? Right? So the average case efficiency says that remove the constants. So average case efficiency has big O of n. Okay, so the order is big O of n, that is average case and worst case. Now best case is there will be only one search, exactly one search. Okay, fine. So now next let's continue. I think we have copied this program. C programs. Yes. Okay. So we have not yet copied. So let's copy. Program to implement linear search and also to find the efficiency. Okay, we have done this. So now let's try the let's try one more linear insertion sort. So let's try insertion sort. The bubble and selection sort you people have to try by yourself. Otherwise, you can request me to do it. I will definitely do it for you. Okay, right? So for time being, we are going to solve insertion sort. Now first, I'll show you how insertion sort works. Okay. Say we have the numbers here like this: 10, 5, 15, 3, 8, 12, 9 and 7. Let us assume these are the numbers. Okay, right? Now we have to sort them. Okay, let us assume we will in ascending order. Now what I'll do, I'll simply imagine in the same array, okay, I will simply imagine there are two arrays. There are two arrays. What are the two arrays? Now say suppose the 10 I have taken. Okay, 10. So there is one element. Okay, and the rest is another array. Okay, so starting from 5 till 7, 5, 15, 3, 8, 12, 9, 7. So they are another array. So 10 is in different array. That is how we imagine. Okay, not there is only one array. Okay, but we imagine that there are two arrays. Okay, right? So here what is that we are going to do is we will consider this 10, okay, which is in a different array, as a sorted array. Okay, we will consider it as a sorted array. Okay, right? So now this sorted array that we have considered here, okay, so this is a sorted array. Please note why it is a sorted array. When there is only one element in an array, it is already sorted. Very simple. Now what we are doing is, so we have two arrays. One is sorted array and another is unsorted array. Which is the unsorted array? Starting from 5 till 7 is the unsorted array. Okay, so here what we are going, we are very simple. We are taking one element from the unsorted array and storing it in its right position in the sorted array. Okay, now 5, can I store it here? No, I cannot store it there. So we have to compare the new element that we are going to store, that is 5, with the elements in the sorted array. Okay, so what are the elements in the sorted array? Only one element. So 5, is it less than 10? I will check. Yes, it is. So the 10 will be shifted to the right. Now I got boundary. Please note I got the boundary. There are no more elements, so simply store it. Now can you see that I got two elements now in the sorted array, okay, all right. So now next, what is that we are going to do? Now next is 15. We are going to take 15. Now 15, is it less than 10? No, so simply place it, so it is in its correct position. Okay, right? Now next, take 3. Now take 3. So here what we have to do, we have to shift 15. Now is 3 less than 10? Yes, so shift to 10. Now is 3 less than 5? So shift 5. We got the boundary, so place it. Okay, I hope you are following, right? Now we have to place 8. So 8, what we will do, how do we do, is 8 less than 15? Yes, so shift 15. Is 8 less than 10? Yes, so shift 10. Is 8 less than 5? No, so that is the right position of 8. I hope you understood. Okay, Now next 12, we have to place 12. Is 12 less than 15? Yes, so shift 15. Is 12 less than 10? No, so place 12. Okay, now these are the elements in the, okay, right. Now we have to place 9. So to place 9, now check if 9 is less than 15. Yes, so shift 15. Is 9 is less than 12? Yes, so shift 12. Is 9 is less than 10? Yes, so shift 10. Is 9 less than 8? No, so we got the right position. Okay, so this is how the that is insertion sort works. So what we are doing, in every iteration, we are taking one element from the unsorted array and inserting it in the right position in the sorted array. That's all we are doing. Okay, I hope you people are trying to understand this. Okay, all right, now let's continue. Now let's write the program for this. I hope you people are understanding. Okay, right. Now what we'll do, program to implement insertion sort. Okay, program to implement insertion sort. Now here what we'll do, we'll take an array. Okay, we'll take an array of type int. Okay, of array size. Okay, comma I, comma j, comma element. Okay, all these variables we need. Okay, I and j, of course, they are loop counters. Okay, right. Okay, now what we have to do, now let's take array size as 10. So now first we will tell the user enter 10 numbers randomly. Why randomly? Because we have to later sort them. So run a loop for I equals 0, which is already done. I less than array size. Okay, right. Okay, and here I plus plus. So here what we'll do, scanf %d ampersand err of I. So we have read 10 elements. Okay, we have read 10 elements. Now we have to sort them. Okay, so do it in the same function, that is main, but good practice is to do it in the different function. So what we will do here, we'll call the function insertion sort of err. Yeah, I think that's it is required. Okay, right. So here what is this, void insertion. Do not forget to write the declaration of the functions. Okay, so it will be int star. That's it. Okay, and then what we'll do, we'll say printf the sorted array is. Okay, right, and copy paste this. Okay, that's it. Here instead of saying scanf, say printf %d ampersand. Okay, otherwise you can also write %5d. Okay, return 0. Now let us concentrate now on the insertion sort function. Void insertion sort. Okay, so here what we'll do, int ptr. Please note, you can write int star ptr, or you can also write like this. Okay, so now here what we will do, for first we need to declare the variables int I equals j equals 0 comma element equals 0. Okay, so here we don't need this element and j. Okay, right. Now let's continue. Please note, we have to start from the first element. We have to start comparing from the second element. Why? Because the first element itself we consider to be sorted. Okay, isn't it? The first element we will take it in will the first element of the array we will consider it as an array of one element, and it is already sorted, isn't it? When there is only one element in array, the array is sorted. So we will start from the second element, because please note, as I shown you here, the 10 we took it here, isn't it? See, that 10 I took, then what did I did? 5 I placed it in its right position, isn't it? Right. Okay, so this is what we did. Okay, so here actually we started something like this. Okay, isn't it? Right. Okay, so now please note here, the first element when we took, okay, and there is only one element in the sorted array. Okay, right. So then the array is already sorted. So from the second element onwards, we will start taking from the unsorted array. That's the reason I equals 1. Okay, now I less than array size I plus plus. So usually all the sorting techniques, in all the sorting techniques, the outer loop will runs for the length of the input array. Okay, runs, that is to fetch or to access each element of the array. Okay, that is of the unsorted array. Okay, so here what we will do is element that we have to insert. Okay, the element to be inserted, what it is, array of I. Okay, the element to be inserted is copied in a local variable, in a temporary variable named as element. Okay, then what we will do is j equals I minus 1. That is where we have to start. So now, where when we are doing the shifting, the inner loop will do the shifts. Okay, will shift the elements to the right. Okay, right. So here to place 3 here, we have to shift 15. We shifted 15 from here to here, then 10 from here to here, then 5 from here to here. Only then we got this empty position. Correct. So the shifting job is done by the inner loop, but how many shifts we have to do, we don't know. Okay, right. So please note, when we inserted 15, we did not do any shifts at all. There were 0 shifts. When we inserted 3, there were 3 3 shifts, that is 15, 10 and 5. Okay, when we inserted say 9, there were 3 shifts, isn't it? When we inserted 8, there were only 2 shifts. So how many shifts will be there, we don't know. So we are using while loop. So when the number of iterations is not known, we use while loop. Okay, so till where we have to go, please note, while j while j greater than or equal to 0 and element is less than ERR of J. So what we have to do? We have to simply shift the elements. ERR of J plus 1 equals ERR of J. Then J minus minus. We have to move backwards. So after that what we will do? We will say ERR of J equals element. That's it. Okay. That's all. Over. So now let's compile this and run it. Yes. So here it is. I'll name the pointer as ERR. Okay, enter 10 numbers randomly. So what we will do? 12, 2, 10, 5, 15, 3, 9, 7, 1, 6. The sorted array is okay. Nothing it is printing. Let's see why it is not printing anything. So here hmm, yes, place the insert the new element into the right position in the sorted array. Shift the elements to the right. Okay, again it is not printing anything. Yes, the reason is I equals 0. That was the problem. Okay, because I had become 10, so here the condition will fail. So I should be equal to 0 there. Okay, now it will, now this will run. Okay, so 20, 10, 1, 5, 3, 8, 6, 4, 23, 15. Okay, now there is something mistake here, so let's correct it. So that is how you have to work. See, now there is some mistake here in the yeah. So here I equals 1, I less than array size, I plus plus. The element we are taking. Okay, so j is greater than or equal to 0 and element is less than Hmm. Okay, I think this should be ARR of j plus 1. Okay, now let's run this again. Enter 10 numbers. So 10, 1, 3, 2, 5, 9, 8, 4, 0, 12. Okay, so now it is properly sorted. So can you observe 0, 1, 2, 3, 4, 5, 8, 9, 10 and 12. Okay, there are 10 numbers which are properly sorted. So now you have to trace this. Okay, please sit and trace the program. Okay, see, I too did some mistakes, as you might have observed. Okay, so what was the mistake? First mistake was it was not printing any numbers at all. Why? So here I forgot to make I equals 0. What was the necessary to make it 0? Please note, here I would have changed. I would have become 10. So here 10 is less than 10. The condition fails and it will never go inside the loop and it will not print any number. So I equals 0 we have to make. Next, what was the error? Here I said ARR of j equals element. Please note, when the element has to be inserted as the first element, so what happens? Okay, j here becomes up to j goes up to 0, then j minus minus means it will make it minus 1. Okay, so ARR of minus 1 is never an index of the array, so it should be j plus 1 here outside the loop. Okay, right? I hope you are trying to understand this. All right. Okay, fine. So now let's continue. Let's try to understand the best case efficiency and worst case efficiency. It is the efficiency of this uh, insertion sort. Now please note here, I will take one example here: 3, 5, 8, 9, 10, 12, 15. Okay, right? So let's take that example. What were the numbers? 3, 5, 8, 9, 10, 12, 15. Some, okay. Now what do you observe here? The array is already sorted. It is already sorted, or you can consider it is almost sorted. Say the next number will be, say, 14. So this is also, almost sorted, isn't it? So what we do here, take the first element. Now next, first element we have taken. Okay, now we have to start from the second element. 5, is it less than 3? No, so place it, insert it. Now 8, is it less than 5? No, so insert it. Now 9, is it less than 8? No, insert it. Now 10, 12, 15. Now next here what we will do, next here what is that we will do is only the 15 we have to shift and place 14 there, isn't it? Okay, so how did this work? Almost linearly. So what did we do? We simply copied 3 to one array to another, as if we have copied one array to another. So one array to another means what is the efficiency? It is linear, isn't it? It is simply linear. Okay, so that is what we have to do here, right? So the best case efficiency of linear search, insertion sort is, I'm sorry, big O of n. Okay, now next is what you have to observe is, please note, this loop, that is outer loop here, the outer loop will always run. Okay, so the outer loop will always run here. So we will write a line for this. Okay, so this is the length of the for loop. Now in that, for every iteration, say this is every iteration, 1, 2, 3, there were 9 iterations. okay, 4, 5, 6 and so on. Okay, so for every iteration here, okay, what we are doing, we are doing so many number of shifts, say some 5 shifts, there might be only 2 shifts, there might be 0 shift, there might be only 1 shift, okay, right. There might be, okay, so many shifts here, and there might be only 3 shifts later, and then again there might be 7 shifts, etc, etc. So this is what, how do you see, this is bilinear. Okay, this is bilinear, or nothing but it is quadratic. So worst case efficiency or best average case efficiency, okay, worst or average case efficiency of the insertion sort, worst case efficiency will be big O of n square, big O of n square. Average case efficiency will also be big O of n square. See, when you will get the worst case, okay, please note, when you will get the worst case, the worst case happens when you are sorting an array in opposite direction. Please note here, say now this array we have to sort, which array, this one, okay, this array we have to sort, okay, in descending order. So let's do it. So 3 I'm taken, so now next what, I have to shift 3, then place 5, then 3, then again what, shift 3, then shift 5, then place 8, okay, then what you have to do to place 9, okay, you have to shift 3, then shift 5, then shift 8, then place 9. So every element when you are placing at the boundary, at this boundary, okay, at the boundary, right, okay, at the boundary, then what happens, the number of shifts will be maximum, the number of shifts will be maximum, okay, right. And when this insertion sort will fail, see, when the list is very big, okay, the array is very big, and we have to apply insertion sort, then what happens, say the last elements, say suppose if we have to them place them in the beginning, say suppose here I got some elements like this, say 30, okay, 30 and 40. So these elements, where they will come, again here, isn't it, right, because we are sorting in descending order. So the last elements, all these elements, they are all coming at the first position, almost near the first position in the sorted array, okay, so which will take too much of time. So mean to say, as the list grows higher and higher, okay, larger and bigger, we should avoid insertion sort, okay. So now please come again, now what is the best case efficiency, big O of n, worst and average case efficiency, big O of n square. So now let's write some notes on this, it's very important, okay. Notes on insertion sort. So what are the note on the insertion sort is, first thing, point number 1, we must use insertion sort only for the arrays or lists of smaller size, okay. We must prefer insertion sort when the list is smaller and we also know that the list is somewhat sorted in a specific manner. Mean to say, see, we want to apply sorting, so we will not simply use blindly any sorting technique, okay. We will first try to study the input, what it is. Say if it is a very small size, Okay, the input array is having only 100, 200, 500 elements. So now to sort this, we can use the insertion sort. Why? When the input size is smaller, insertion sort works better. Okay, right? Okay, and then when the input size, we know that it is almost sorted in a specific manner, then definitely you must use insertion sort. Why? You will get a efficiency nearer to big O of n, which is the best sorting efficiency. Okay, so when to avoid, we must avoid insertion sort when the list size is very big. Okay, so these are the 3 points that you have to note. So when the list is smaller, okay, when the list is smaller, you can use insertion sort. But when the list is smaller and you know that the list is sorted in a specific manner, okay, is almost sorted, it is almost sorted but not completely sorted, so then you must and should use insertion sort. When the list is almost sorted, we know that it is almost sorted in a specific manner and the input list is size is small, then use insertion sort. Okay, right? And when to avoid insertion sort when the input list is very big. Okay, when the input list is very big and you don't know how the list is sorted. Okay, I mean to say, see, even if a list is unsorted, but still to some extent we may be able to guess whether it is sorted to some extent or not. Okay, fine. So this is the program. Let's copy it and I'll save it for your future reference. Okay, program to implement insertion sort. Now what are the other programs that we'll do? Yeah, there are some matrix problems and other sorting techniques. So now they are all very easy. So what we will do is we'll move on to string handling functions. Okay, so we'll move to strings. Let me check if there are any uh, doubt. So no one has raised any doubt, so I'll continue. Okay, right. Now what is a string? Now please note, I'll say a3 dot equals r m, say something. So what are these things? They're simply some set of characters. Now do they have any meaning or do they have any implicit meaning here, these things? No, not at all, isn't it? However, if I say Tamil, then yes, it is having some meaning. It is the name of one of the regional languages of India, isn't it? Okay, one of the oldest languages of the world also. Okay, so now here these 5 characters together, okay, they make up a name, isn't it? Right? So it has a meaning, but how about this? These characters put together, they don't have any meaning. Okay, so please note, what is a string? A string is a set of characters that makes up a data. Okay, a string is a data, very simple. Okay, a string is a data made up of multiple characters. Okay, a string is a data made up of multiple characters. A string is a set of characters that makes up one data. Okay, right. But the thing is, how to store a string? How to store a string? Okay, we can store a string. I'm going to remove this. See, we can store a string in an array. That is a very good idea. Now take an array, something like this. Okay, here what we'll do? Okay, right. So at the last we will store /0. Okay, right. So this is a string. Where did we store a string? In an array. Why we have chosen an array? Because in an array all the elements will be stored in contiguous memory location. But why did we choose array again? Come on, because we have to store here multiple characters. We have to store so many characters, and that is the reason we have chosen a array to store the elements. Okay, what are the elements? Characters. What these characters, do they have meaning individually? No. A, E, G, U, T, none of these characters here in the string have meaning implicitly and individually. Telugu, okay, it is having meaning. It is again name of one of the regional languages in India. Okay, right. Okay, so now please note, so what did we understand? To store a string, we store a string in an array. But wait, okay, fine. Why do we need this null character? Why do we need this character? Let's check. Now for that, let's take few more examples. Okay, so now here I'll say okay, I've taken one more string, then okay, then Hindi. Now here what you observe is all these three strings, they have different number of characters in them. Okay, different number of characters. So now when what do? We send this data to the functions. Okay, different functions. But what do we have to send? We have to send the first address, that is the address of the first element in the array, isn't it? Because we have stored this data in an array. Okay, right. So how to pass this entire string to a function? Simply pass the address of the first element. Okay, are you following? Okay, fine. That function received an address, so now it has to print this data, but it should know how many characters are there in the array. That's very important. Okay, so how many characters are there in the string? Okay, how come the functions will know? So what we will do is very simple. We will append the /0 at the end of the string. Okay, so now what happens? Now, so the function